So hey everyone, this is Gilbrian Harmelio and this is activity 6 AMC 221. So core OpenGL concepts. So what is core OpenGL concept? So OpenGL is a powerful cross-platform graphics API that provides a rich set of tools for rendering 2D and 3D graphics. Now, core concepts of OpenGL. First one, we have coordinate systems. So coordinate systems are crucial in OpenGL for defining the positions of objects and how they are viewed onto the screen. So here we have in coordinate systems object space. As you can see here, this is an example of object space. So object space is a local coordinate system of the object. It defines the shape and the structure of the object relative to a local origin. Next one is world space. World space is the positions of objects within the scene, or it positions the object within the scene. The transformation from object space to world space typically involves translation, rotation, and scaling. Next one, we have a view space, or the camera space, or eye space. So view space is the coordinate system relative to the camera's viewpoint. Objects are transformed from world space to view space through a view transformation, positioning them relative to the camera, as you can see here. Next one is clip space. So what is clip space? This coordinates after applying projection transformation. Objects are transformed from view space to clip space when they are prepared for clipping. So clipping determining what is within the view frustum. So next one is normalized device coordinates, or NDC. This is coordinates are normalized to a range of -1 to 1. This clip space coordinates are divided by their W component to get the NDC. Next one, screen space. So screen space is the equation for the screen space. So screen space is the final 2D coordinate system of the screen. NDC coordinates are transformed to screen space through a viewport transformation, mapping them to pixel coordinates. Next one, vertices. So what is vertices? Vertices is a vertex in a point in 3D space defined by its coordinates x, y, z. Vertices are fundamental in defining the shapes of geometric primitives like triangles and lines. So here we have vertex attributes. So vertex attributes is additional data associated with vertices such as color, normal vectors, and texture coordinates. It is used to store in vertex buffer objects and used for shading and lighting calculations. Next we have vertex buffer objects. So vertex buffer objects, or VBS, in OpenGL objects that stores vertex data, and this enables the efficient uploading and management of vertex data to the GPU. Next one is element buffer objects. OpenGL works exclusively in triangles. It has partial support for squares and other shapes, but those have been deprecated for a very long time and should not be used. You could do it by defining 6 vertices to make 2 triangles that look like they're one shape, but that would be a waste of time since a rectangle only needs 4 vertices. So, element buffer objects are stored indices that define which the vertices make up each primitive. Facilitates the use of indexed drawing, reducing the redundancy of vertex data. Next one, shaders. So here we have vertex shader. This is the code for the vertex shader. So what is a vertex shader? The vertex shader is a programmable stage in the pipeline. This transforms vertex coordinates from object space to clip space and can pass transformed data to the next stages. Next one is fragment shader. So this is the code for the fragment shader. So fragment shader handles the per pixel color and texture calculations and determines the final color of each pixel. Now, shader programs comprises multiple shader stages like vertex and fragment shaders and link together to form a complete rendering pipeline. So under that is transformation pipeline. So transformation pipeline in OpenGL are applied sequentially to the position and orient objects within the scene. So under that we have model transformation. This converts vertices from object space to the world space. We have view transformation. This converts vertices from world space to view space. The next one is projection transformation. Converts vertices from view space to clip space. And viewport transformation converts NDC to screen space. And the rendering pipeline is for the screen. Rendering pipeline is a sequence of steps, converts 3D objects into a 2D image.